So today, instead of giving you a sequence and then asking you just to guess and check to find the rule for the sequence, we're going to learn about a specific type of sequence, and then I'm going to give you the formula to finding the rule for that one. So this is going to be a little bit more methodical and more what we're used to. Today we're looking at what is called an arithmetic sequence. So an arithmetic sequence is a set of numbers created when a constant number is added. So it's just like the last example that I just did. They added 6 each time. So when we're adding the same number each time, that's called the common difference, and the variable for that is d. Put a box around that so you don't lose it, to the previous term. So this means that I start at a number, and then I add the same number each time to get the next term. Okay, so just like number 38. So what we want to do in example 1 is I'm just asking you, yes or no, is the sequence arithmetic? So look at part A. How much is it increasing this way? Plus 6. How much about here? Plus 6. And this one? Also plus 6. So A is arithmetic, yes? Okay. So yes, it's arithmetic. Check B, see if it's arithmetic. What are we adding between -8 and -4? Positive 4. What about 4 to 0? Plus 4. So far, so good. What about 0 to 6? That's plus 6. Okay, and 6 to 12? Plus 6. So is B arithmetic? No, not arithmetic. Okay, so arithmetic means I'm adding the same number each time. Okay, so we get a formula. I put it nice and big in a box for you. Formula for arithmetic sequences. A sub n, that's the term number, right? Equals D. D is that common difference, the number that you're adding each time, times n minus 1. So what term number am I on? Minus 1 plus A sub 1. A sub 1 is the first number of the sequence. N is the term number. Okay, so if I want you to find the third term for n, you're going to plug in 3, and then you're always going to plug in for A sub 1 whatever the first term was, not the term number, the first term. Okay, so let's look at the example right here. I already did all of the work off to the side. What is this increasing by each time? 5, right? We're adding 5, adding 5. Adding 5. So when I plug it into this formula, A sub n equals 5 is the common difference times n minus 1 plus 10. 10 is the first number, or the first term of the sequence. Then we distribute the 5 because you need to simplify this as much as possible. So that's 5n minus 5 plus 10. And then when we combine like terms, we get A sub n equals 5n plus 5, and that's what your answer is going to be. Okay, so you're just going to plug all the information that you know into the formula and then simplify it as much as you can. Does that make sense? Okay, so for example 2, what we're going to do is we're going to write a rule for the nth term just like it was done in the example up here. And then you are also asked to find the 20th term, A sub 20. So after we find the rule, we have to plug in and find A sub 20. So looking at A, what are we increasing by each time here? -3, right? We're subtracting 3, subtracting 3, subtracting 3 each time. So let's plug it in. A sub n equals D is -3. That's how much we're adding each time. So -3 times n minus 1. We don't know what n is yet. Plus A sub 1, that very first term, which is -7. So plus -7. Okay, so let's distribute. That's A sub n equals -3n plus 3 minus 7. So A sub n is equal to negative 3n minus 4. And that's the rule for the nth term. And then we want to find a sub 20. So we're going to take a sub 20 and plug it in to this formula that we just found. So negative 3 times 20 minus 4. So a sub 20 equals negative 3 times 20 is negative 60 minus 4. So a sub 20 is equal to negative 64. So much nicer than guessing and checking, right? Okay, will you guys do part B then? So how much on B are we increasing by each time? 9. D is equal to 9. So when I plug that in, a sub n equals 9 times n minus 1 plus the first term, which is 59. Oh, thank you. Sorry, guys. Plus the first term, which is 59. Okay, so we distribute. So a sub n equals 9n minus 9 plus 59. So a sub n equals 9n plus 50. Is that what you got?
Yeah.
Okay. This does not look like a 9. Alright, so then a sub 20 is 9 times 20 plus 50. So a sub 20 is 180 plus 50. So a sub 20 equals 230. Part C. I have a sub 11 and D. I don't have anything else. Can I still find a sub n?
Yes.
I can. What can I do? Yeah, let's plug in what we know. A sub 11, which is equal to negative 57, and then let's plug that into the formula. So D is negative 7 times n, which is what? I know what n is. 11, right? So 11 minus 1. I don't know what a sub 1 is, so plus a sub 1. So this time we're going to solve for a sub 1. So that is negative 57 equals negative 7 times 10 plus a sub 1. So that is negative 57 equals negative 70 plus a sub 1. So a sub 1 equals positive 13. Okay, so now I know what D is. I know what a sub 1 is, so what's a sub n? D, negative 7 times n minus 1 plus what?
13.
Plus 13. So even if they don't give me the sequence, I can still figure it out using the information I know. They will never ever give you a problem that doesn't have enough information. You just have to be a little sneaky about how you get what you need. So what's a sub 20 then? So a sub 20 is negative 7 times 20 minus 1 plus 13. So a sub 20 equals negative 7 times 19 plus 13. Negative 7 times 19 gives me, oh, I did all of it in one step. Negative 7. Negative 133 plus 13. So a sub 20 equals negative 120. Okay, so if you are given a term and D we can just plug in what we know to the equation to find what's missing, and then we just plug it back into the original formula. Make sense? Okay. Yeah. D is a little bit trickier. I am given a sub 7, which is equal to 26, and a sub 16, which is equal to 71. I have no idea what a sub 1 or what D is. So let's plug what we know into the formula first, and then we'll see what it looks like we can do. So a sub 7, that's 26, equals, we don't know what D is, so D times 7 minus 1 plus a sub 1. And a sub 16, that's 71, equals D times 16 minus 1 plus a sub 1. We can simplify these a little bit, right? This is 26 equals 7 minus 1 gives me 6 times D, so that's 6D plus a sub 1. And 71 equals 15D plus a sub 1. Is everybody okay with what I've done so far?
Why did you do two separate?
I did two separate because they gave me two separate terms. So I plugged both of them into the formula. Now I have two equations, two variables. Any ideas of what we can do? Elimination, right? Okay, we need to change one of these to negative. Which one? How about the top? So we want to change it to make everything negative. So I just drew in the negatives. Okay, 71 minus 26. What does that give me? 45. 15D minus 6D. 9D. And a sub 1 minus a sub 1? They eliminate. So what does D equal?
5.
So D equals 5. Okay. So I know what D is. How do I find a sub 1? Plug it back in. Where do you guys want to plug it back in? 26? Okay, so 26 equals 6 times 5 plus a sub 1. 26 equals 30 plus a sub 1. Subtract 30 from both sides, so a sub 1 equals negative 4. Okay, so what is the rule here? A sub n equals D. What's D? 5 times n minus 1 plus a sub 1, which is negative 4. So minus 4. Done. Find a sub 20, you just plug it all back in. I ran out of room, so we're not going to do it. You guys okay with that? Okay. So if they only give you two terms, you use a system of equations. If they give you one term and D, you just plug in what you know to solve for the missing part. Okay, so what about series? We also have arithmetic series. Now a series means that we're just adding everything together. So an arithmetic series is the expression formed by adding the terms of an arithmetic sequence together. Okay, there's a formula for this also. The sum of the first n terms of an arithmetic series is S sub n, that stands for the sum. Whatever you plug in for n, like if I plugged in 5, it means the sum of the first 5 terms, equals n times the first term plus the last term divided by 2. So you're taking the mean of the first and last term, and then you're multiplying it by the number of terms that we added together. So you take the first and last term, divide by 2, multiply by how many terms there are. So let's look at example 3. Find the sum of the arithmetic series, the sum from 1 to 12 of 2 plus 7i. So in order to use this formula, we need to figure out what a sub 1 is and what a sub n is. What's n here? How many terms am I adding together? 12 of them. So we need to find out what a sub 1 is equal to by plugging it into here. 2 plus 7 times 1. And we also need to figure out what a sub 12 is. 2 plus 7 times 12. So let's figure those out. A sub 1, 2 plus 7, so a sub 1 is 9. A sub 12 is 2 plus 7 times 12 gives me 84. So a sub 12 is 86. Okay, do I have everything I need now? Yes, so I'm going to use this formula. The sum of the first 12 terms equals n. N is 12, the number of terms we're adding up, times a sub 1, 9, plus a sub 12, 86, all of that divided by 2. So the sum of the first 12 terms is equal to 12 times 9 plus 86 is 95 over 2. Now 95 divided by 2 doesn't give me a whole number, so instead I'm going to reduce these two. 2 goes into 2 once, 2 goes into 12, 6. So we have 6 times 95. So S sub 12 is equal to 570. So there's a little bit more work involved here. You have to find the first term, you have to find the last term, and then you can plug everything into the formula. So right now, will you guys find the sum of the arithmetic series from 1 to 18? That's an 18. Of 14 minus 6i. So do all of this work for part B. Okay, so before we can find the sum, we first need to find the first term and the last term, which in this case is 18. So a sub 1 equals 14 minus 6 times 1. So that's a sub 1 equals 14 minus 6. So a sub 1 equals 8. Not bad. A sub 18. That's 14 minus 6 times 18. So a sub 18 is equal to 14 minus 6 times 18 gives me 108. So a sub 18 is equal to negative 94. So far so good? Okay, so we take these and plug it back into the formula for the sum. So the sum of the first 18 terms, we take the first two terms and find their mean, so we add them together and divide by 2, and then multiply by the number of terms. The number of terms we are adding is 18. So S sub 18 gives me 18 times negative 86 divided by 2. So you have two options here. You can divide this by 2 or you can reduce this way. I'm going to do 18 times negative 43. So S sub 18 is equal to negative 774. Is that what you guys got? Is it okay that it's negative? Can numbers add up to be negative? Yeah, you can have a sum that's negative, so having a negative number is totally okay. So, we have two formulas now for sum of an arithmetic series and for finding an arithmetic sequence, which should be a lot easier than guessing and checking like we did yesterday. So this should be much nicer. Okay.